Welcome, everyone. Good morning. Welcome to this very, very special event at Think Corner. My name is Anni Pokela. I am one of the co-founders of Operaatio Arktis and one of the executive producers of this event and the ATLAS25 conference. It's going to be a very interesting discussion. I feel like we're in a very, very difficult predicament right now in this sort of poly-crisis. Climate discussions haven't been really trending as of late, and though we are going to have maybe some very difficult, even jarring revelations today, some very challenging conversations even. These two speakers, I'm glad to say, are not people who hold back. They will not sugarcoat the situation we're in. But even though it might be difficult, I do really think that that's sometimes what is needed. And if your heart gets a bit broken today, when it comes to this really horrible situation, that might just be what it takes to really be able to reconsider what we have to do, to reconsider what is effective, and yes, what has to be done. But before we start, we're going to have some words from our co-organizers. So I'd like to welcome to the stage Rosa Rantanen and Norppa Kivimäki. If you can just introduce yourself quickly. Rosa, you can go first.
Yes, thank you, Anni. Thank you for all the organizers. Nice to be here. My name is Rosa Rantanen. I work at the University of Helsinki, and I represent the Safer Climate Network that works at the intersection of science and civil society and arts, and it's part of the Atmosphere and Climate Competence Center, ACCC, that is a co-organizer of this event.
Yay. Thank you so much for inviting me here. I'm Norppa Kivimäki. I'm part of the Youth, Nature and Climate group that operates under the Prime Minister's office. I'm the coordinator of this group, and it's really nice seeing so much people here.
Yeah, and because the intergenerational aspect of climate change obviously is a big aspect of this issue. We're just going to talk to Norppa a bit about like how you, as someone who sort of in the capacity that you can represent the young people of Finland. So I would first kind of ask you about this sort of temporal aspect of intergenerational justice. There's often like either this framing of it's not about the future generations, it's about the people suffering right now, the inequalities that we're experiencing now. And also sometimes this very powerful framing of the generations to come, people who very literally have not been born yet and don't exist yet. So how would you sort of, how do you view these different framings?
So I think they're really intertwined. You can't really separate them. You can in a theory level, but they're the structures that are oppressive and that are neglecting the climate actions as the climate politics of today. They are shaping not only the current world, but also the world to come. So it's not really about us or them or they or those. It's about us all, and you can't really talk about climate justice without talking about the global south, without talking about all the generations to come. So it's really, it's a cliche, but it's everyone's.
It's cliche for a reason.
Yeah, exactly.
So you have been working a lot with the youth perspective, and it's been quite clear that the youth has specific ideas and demands what to do with climate policies. Could you elaborate a bit on that? Like, what is the message that you hear from your peers and working with the youth here in Finland and beyond?
So it's quite funny, actually. It doesn't really differ from the adults. The young people, they want scientific knowledge that the climate politics based on, and they want actions that are not only symbolic, they want clear actions that do have a meaning. They want the Finland's current government to stick to the climate change
targets,
yeah, and and they want to see the carbon sinks go up, they want to see the consumption go down. It's really very simple things, and it's sometimes quite frustrating when you listen people talk about young people and they somehow feel like we have different demands than the scientific professionals right now that are saying the same thing over and over again.
Yeah, and just to jump on that, there's a real tension between this horrible, this information that we have about where we are, and we're going to hear about that soon, more on that soon. This situation, and then on the other hand, trying to inspire hope in the young generation, and this tension between despair and hope. How do you view this tension, and shouldn't we kind of ditch those both and just focus on cultivating agency instead of hope?
I think you said it perfectly. I'm not a fan of false hope or empty hope. I think it can be as paralyzing as fear, as desperation. So I think what's most important right now is to focus on climate realism, focus on the truths, even the uncomfortable, even the high-risk scenarios that we'll be hearing today about. And I think we can't sugarcoat things, and we can't kind of treat people in a way that we think that they couldn't handle things. People see horrible things every day about Gaza, about Ukraine, all sorts of things. We can't really change our message just because we think they can't handle it. They can, and they should.
I definitely agree. We're now going to move on to Mervi's presentation on the role of researchers in this whole situation. So thank you all so much for co-organizing this event with us, and let's welcome to the stage Mervi.
Thank you. Thank you.
Good morning. Hyvää huomenta. Thank you for the Operaatio Arktis for inviting me to speak today. It's a big honor to be here and share our work with you. I'm representing here a research consortium, Democratic Epistemic Capacities, which is founded by the Strategic Council of Finland. And I'm presenting some insights of our ongoing work with my colleagues Risto Kunelius and Marko Ampuja. We are from Media and Communication Studies. Our study is about how Finnish climate researchers and experts are navigating the climate crisis. They are very close to the climate crisis because of their expert knowledge. It is very emotional for them because of that. So we are asking how they are navigating this critical juncture in their research and also in personal lives. Our starting point and empirical focus is the cultural moment or a sense of it's too late. This concept, well, we have a lot of concepts for this juncture, and we chose this it's too late because it contains both possibilities and endings. And Susanne Moser, who first wrote about climate change communication from this perspective, she highlighted that this it's too late means that instead of thinking that it's all over, we have to think what's possible, what's still possible to do, what's there left to do. And as one of our interviewees said, this is because every degree matters. So reflecting on what is not too late, what the future possibilities are is the responsibility of climate scientists and climate communicators today. So, in our study, we combine question about scientists' responsibilities and their lived emotions, because responsibilities are shaped by emotions and vice versa. And we ask how they make meaning at this point of their roles as public experts, how they manage their emotions, and how they take responsibility when they are witnessing that climate action is lacking, and also the public debate is becoming more polarized. What we did in practice is that we interviewed Finnish climate scientists and experts, not only from natural sciences, but also from social sciences. So we have a good group of interviewees, and many of them have taken major responsibilities concerning the fight against climate change by taking part in Finnish climate panels and working groups, so being very close to the political power. We wanted to know what kind of different strategies they have for coping with the current situation. And we identified, these are preliminary findings, we identified, let's say, four discourses which showed how they make sense of their professional role, of their role as expert in this juncture. These are both overlapping, but also there are some differences down to the disciplinary differences. I start with seeing work, the climate change work research as a moral imperative. This was very common because the sense of responsibility was articulated through this idea that all action matters, and it's a moral imperative of continuing to produce new knowledge and to communicate findings. And the researcher we interviewed, they saw some kind of empowerment in this process of working regardless of any certain outcome. While many researchers at some point said that the game is over or we are doomed, however, there was always kind of another view that they propagated regarding hope. Interviews show that hope is a really complex concept or emotion. But in the interviews, the hope doesn't refer to any possibility of finding one decisive solution or any linear progression anymore possible. Instead, hope is a practice. So they emphasize the need to cultivate this practice by keeping working, by keeping communicating the results over and over and over to the public and to the political decision makers. Next, related to the first one, is the power of or comfort of collaboration. They highlighted the moments and events and networks and communities where they felt that they got new sense of meaning for their work. Communities and networks where they felt that their work was appreciated and also understood, and they emphasized the possibility of framing the meaning of their work themselves, often referring to media which picked some issues or softened their message. And the third discourse was enlarging social responsibility, which has been largely debated in recent years. This idea of closing window, like the time window closing, had stimulated activism among researchers. So several interviewees saw that this kind of dispassionate silence or not acting on the knowledge they are producing is not possible anymore. So they highlighted the need to contribute to a more informed public discourse, to the public understanding that everyone can and should be an active agent. This was not a unanimously shared position, but especially early and mid-career interviewees considered to engage in street activism in addition to other means of advocacy. So there was this, at least, talk about the need to enlarge researchers' social responsibility. Where did I put the thing here? And lastly, and obviously not surprisingly, upholding the authority of science as we traditionally understand it, or as it understood in some disciplines, was also a kind of prominent position the scientists took. But this was also sort of modified, if I may say, by the realization that because some other researchers have taken a more active approach for acting on research, they have the luxury or pleasure to carry on and hold on to this neutral or objective position of a scientist who produces and assesses but does not act on the results, on the findings. Often related to this position was the experience that in Finland, when you engage with politicians, you are very easily outed if you are labeled as an alarmist or a leftist or something unwanted by the policymakers. So it was not perhaps always the choice, the first choice of their own, but it was about the necessity to be able to collaborate with policymakers. I'm closing with some summing up and some new arguments. In our study, we wanted to hear from the researcher about how they feel about the development, let's say, last 10 years, how they see that the policy making concerning climate change or how media debate has changed. And it was clear that there had been this falling in kind of becoming more anxious, becoming more angry about the development. That many said that when during in times of Paris Agreement, they still had this idea that things are progressing steadily. That illusion has disappeared, and it was very kind of a striking moment when one interviewee said that he couldn't believe at those times that today, in addition to fighting against climate change, he's also fighting against fascism. So that the polar crisis we are experiencing is also adding to the toll of researchers. However, as I already said, hope was found in the ongoing efforts to communicate research and take action. And I would like to end up with this activism and advocacy position that overall climate advocacy was supported as a legitimate position for a scientist, for a researcher, even if it was typically seen as incompatible with the role of a policy advisor. Overall, I can say that the researchers today, they are embracing more and more responsibilities for climate change, for climate science. So they are wearing many hats at the same time, and this is something we all should do, and it's a multidisciplinary responsibility. Thank you.
Thank you so much, Mervi. Thank you so much. Really, really insightful stuff on what the changes are that are going on in this field. So, next up, we have a speaker who really needs no introduction. For over 4 decades, he's been one of the most courageous voices in climate science. And he's the scientist that first brought global warming into the world's attention when he testified before the US Congress in 1988. He is the former director of NASA's Goddard Institute for Space Studies and the current director of the Climate Science Awareness and Solutions Program at Columbia University. His groundbreaking research has really shaped our very understanding of the Earth's climate system. We had the amazing privilege to collaborate with him on his latest report on the acceleration of global warming. And that's work that directly speaks to why we're all here today. So it's my great honor to welcome to the stage Dr. James Hansen.
Thanks very much. Good morning. Climate change is characterized by delayed response and amplifying feedbacks, which are a recipe for intergenerational injustice. So we have an obligation to clarify this and to not shirk from describing the implications. Climate sensitivity is the most basic issue. Jules Charny, the Charny sensitivity refers to the case in which ice sheets on Greenland and Antarctica are fixed. Charny's estimate had a huge uncertainty from 1.5 to 4.5 degrees. Today, the best estimate of IPCC is still 3 degrees. If there were no climate feedbacks, sensitivity, ECS, would be 1.2 degrees, which is the warming needed to radiate 4 watts per meter squared of energy to space, which is the amount of radiation that doubled CO2 blocks from the Earth's surface. Water vapor and sea ice feedbacks are approximately double ECS to 2.4 degrees. Cloud feedback is the big uncertainty. Charney based his estimate on 2 GCMs, global climate models, that differed in their treatment of moist convection, cumulus convection, as I will discuss later. I will conclude with more than 99% certainty that climate sensitivity is higher than 3 degrees, based on 4 independent evaluations. Paleoclimate should provide our best measure of climate sensitivity. We can compare 2 equilibrium climate states, and if we know the forcing that maintains the climate change, we have a direct measure of climate sensitivity. Ice core data reveal atmospheric composition during the last glacial maximum, the LGM, 20,000 years ago. But we also need the global ice age temperature to infer sensitivity. The large CLIMAP and MARGO projects estimated that the LGM was only 3 to 4 degrees colder than the Holocene, the present interglacial period, based on the distribution of microscopic species in the ocean, which is a dubious measure of temperature. Just recently, Jessica Tierney used chemical proxies, finding that the LGM was actually 6 to 7 degrees colder than the Holocene. And Alan Seltzer used noble gas abundance in groundwater deposited during the last ice age and found temperature consistent with 6 to 7 degree global cooling. The upshot of 6 to 7 degree cooling, LGM cooling, is climate sensitivity near the upper end of Charney's range. This paleoclimate data by itself excludes the IPCC 3 degree sensitivity with more than 99% confidence. Source number 2 is the rapid, strong darkening of Earth in the past 25 years. Satellite data show that Earth's albedo, its reflectivity, decreased 0.5% in the last 25 years. So sunlight absorbed by Earth increased 2 watts per square meter. That's a big deal. But don't double count it. This is not a 2-watt climate forcing. Most of it is climate feedback. Part of the albedo change is due to decreased aerosols, small particles in the atmosphere, particulate air pollution, which is a forcing that might be as large as about 0.5 watt. But most of it has to be cloud feedback. Such a large cloud feedback implies high climate sensitivity, surely larger than 3 degrees, but it's hard to say exactly from this non-equilibrium change until the data record is longer. Source number 3, global temperature change in the past century, is the most ambiguous source, but it is the one IPCC focuses on. Global temperature is an ambiguous measure of sensitivity because there are 2 large climate forcings, greenhouse gases and aerosols. And aerosol forcing is unmeasured. The crucial period begins in 1970, when temperature began to rise rapidly. IPCC takes aerosol forcing as nearly constant from 1970 into the early 21st century, in which case aerosols have little role in global temperature. Global sulfate emissions are the basis for IPCC's estimated aerosol forcing. But aerosol forcing occurs mainly via the effects on cloud formation that are nonlinear. Aerosols added to a pristine air have greater effect. During 1970 to 2005, aerosols spread more globally into Southeast Asia and over the ocean as ship traffic increased, surely causing aerosol cooling. IPCC's aerosol forcing requires climate sensitivity near 3 degrees to match 1970 to 2005 warming. But if aerosol cooling increased half a watt, the best fit becomes 4.5 degree sensitivity. We can discriminate among these 3 cases by asking which one fits the entire period, 1850 to 2004, best. And the answer is 4.5 degrees sensitivity. But this observed warming is the weak indicator of sensitivity. Information source number 4, planetary evolution, is interesting. To appreciate it, let's go back to Charney's 1979 study. Charney focused attention on moist convection, cumulus convection, which lifts moisture and heat from low levels to the upper troposphere, reducing low clouds and increasing upper-level water vapor and cirrus clouds. In Charney's study, models using layer average adiabatic adjustment to move water vapor and heat vertically yielded a sensitivity near 2 degrees. But models that parameterized moist convection, allowing moisture and heat to penetrate to higher levels, yielded 4 degrees. Well, Charney took the average of these as his best estimate. But we now can indirectly test the effect of cumulus convection, thanks to a version of the Goddard Institute model developed by Gary Russell that can be used for a wide range of climates. Runaway snowball Earth occurs in the model when CO2 declines to 1/8 of the 1950 CO2 amount, a forcing of -12 watts per meter squared. That's equivalent to a 6% decrease of solar irradiance. Solar irradiance is changing 1% per 100 million years. So 600 million years ago, solar forcing was -12 watts per meter squared. And indeed, the last snowball Earth, when land ice reached sea level at the equator, occurred 600 million years ago, which provides a nice check that supports the high climate sensitivity. The conclusion is that climate sensitivity is substantially higher than IPCC's best estimate, and negative aerosol forcing exceeds their estimate. So, between those two, we've got a big problem. It's solvable, but we must understand the situation and the options quantitatively. Accelerated warming since 2010 is real. It's forced. It's not feedbacks running amok. Global temperature has now reached 1.5 degrees, averaged over the Niño cycle, and it's headed higher. How do we know that? Spatial and temporal distributions of absorbed solar radiation measured by satellite helps us understand this, even though it's hard to apportion between the aerosol forcing and the cloud feedback. Increased absorption is mainly in the northern hemisphere, especially over the North Pacific and North Atlantic. Its timing in the last 10 years suggests that the ship aerosols have more effect than the reduced China aerosols, because the regulations on ships were changed in 2015 and 2020, which reduced the aerosols from ships. But it's a secondary issue as to the apportionment between China and the ships. Aerosol forcing increases heat radiation to space immediately, while cloud feedback grows only slowly as the global temperature rises. So heat radiation to space, again, the temporal change of that, suggests that aerosol forcing was added mainly since 2015. The large increase of heat radiation in the past 2 years is a response to the large jump of global temperature in those 2 years, which reduces Earth's energy imbalance. But the imbalance is still more than 1 watt per square meter, which is double that during the first decade of this century. The implications are great. The 1.5 degree warming level has been breached, and global temperature will rise much higher because the planet is still out of energy balance. We don't need to wait 10 years to conclude that. Someone should inform the United Nations Secretary General, who keeps saying that we can still keep warming below 1.5 degrees. In fact, global warming certainly will exceed 2 degrees. Greenhouse forcing is increasing at the astounding rate of almost half a watt per decade. The RCP 2.6 scenario, which was designed to keep warming under 2 degrees, is now impossible. We are closer to RCP 8.5. We cannot keep warming below 2 degrees without purposeful actions to alter the planet's energy balance. The problem is still solvable, I believe, but young people need to be honestly informed about the situation and how old people screwed up. We must get the carbon intensity down of our energy down to near zero by mid-century. But in 50 years, the world only reduced from 0.8 to 0.7. Sweden and France showed how to get halfway there in the 1970s when they decided to build nuclear power plants. Going the rest of the way would have required a rising carbon fee and development of next-generation nuclear power. Instead, the opportunity to address climate change was abandoned. 33 years ago, Al Gore and Bill Clinton were elected, and in the first State of the Union address, Clinton announced, "We are terminating R&D on nuclear power, which is not needed." In so doing, they tied one arm of young people behind their back. Now, other old geezers want to tie the other arm of young people behind their back and pass laws that say you are not allowed to take action to purposely alter Earth's energy balance. For example, with solar radiation management. So then the old geezers go off to die, and young people are left with 2-degree global warming locked in, out of their control, and both arms tied behind their back. So why is this important? 10 years ago, we wrote a paper saying that 2-degree warming is highly dangerous because it will lead to shutdown of the overturning circulations in both the North Atlantic and Southern Ocean by mid-century, and probably multimeter sea level rise within 50 to 150 years. Reaching these conclusions requires using information from paleoclimate, from modern observations, and from climate modeling, all in the same paper, all in the same head. It's hard, but we can only get to answers soon if we use all sources of information. An IPCC lead author tried to block publication of this paper, which is the same problem I had in 1988, where they do not want to look at all of the information from the different sources. They look at a given temperature curve linearly and say, well, we can't yet say for sure. Well, we've got a lot more information. Nevertheless, although this paper then was reviewed by 4 referees, and all of them except the IPCC lead author agreed it should be published, but then the editorial board got involved and changed the title from "is highly dangerous" to "could be dangerous." That is scientific reticence on steroids. A crucial point in our paper was the first description of the feedback that occurs with melting of ice shelves. Increasing ice melt and increasing precipitation reduce the density of surface water in the polar oceans, thus blocking the escape of heat from the deep ocean, which then accelerates the melting of the ice shelves at depth. There is evidence of this feedback in paleoclimate, in modern data, and in our global climate model. Models need to correctly simulate deep water formation along the coast of Antarctica, which our model did. So, are we doomed to have large sea level rise and lose a majority of the world's large cities, which are mostly coastal? We did GCM experiments anticipating that this Antarctic bottom water formation feedback would work the other way if we cooled the Southern Ocean surface with solar radiation management, assuming stratospheric injection of Pinatubo-like aerosols in 4 different areas, as shown by the shading here. These were done for a meeting in Xi'an, China in 2018. As expected, the stratospheric aerosols produced global cooling at the Earth's surface. The important result is that the Antarctic bottom water formation speeds up if you cool the surface, which opens up the escape valve of heat from the Southern Ocean. which cools the ocean at just the depths that are most effective for stabilizing and even regrowing the ice shelves. My point is that that large sea level rise is not necessarily inevitable. We may be able to take actions to avert it, but we need comprehensive research to address this issue. One other merit of stratospheric aerosols is shown by the airborne fraction of fossil fuel CO2 emissions. In the 2 years after the Pinatubo eruption, 1991, 1992, 75% of fossil fuel emissions were taken up by the ocean, the soil, and the biosphere, the most of any year in the entire record. It seems that a little cooling is good for the planet. People might also benefit from a little cooling. The experiment has been done in nature by the volcanic eruption. The danger in taking actions likely to be smaller than the dangers of not taking action. Finally, I would like to advocate that we scientists work with our Chinese and Indian counterparts. Such cooperations may help our governments understand that those countries are not our enemies. China is doing a spectacular job of moving toward clean energies. If we would work with them, we could drive the carbon intensity of energy down rapidly. We're not doing that. We could do that, but it requires some fundamental actions. We have allowed climate to reach a precarious state, and the world will soon understand that it is now a hard problem. Nevertheless, I argue that the solution is now as simple as 1, 2, 3. But these things are not happening, even though they're sensible. And if I make one more comment, the bottom line of the book that I'm writing now, Sophie's Planet, is that the way to solve the problem is to get the role of money out of the United States government. The public in the United States knows that Washington is a swamp of special interests. The reason we needed to create an enemy in China, and if you start talking about them as an enemy, eventually they become an enemy. It's like the parable in the Bible about the man who asked, he's coming to a new city, and he asked a man there, what are the people like in this city? And he said, well, what were they like in the last city? And he said, they were all crooks and bums. And he said, well, they're the same in this city. Then when the next guy came and asked, and he said, well, the people in the city I came from were all honest, hardworking people, and they would give you the shirt off your back if you needed it. And he said, well, they're the same in this city. So if we treat China like an enemy, then they become an enemy. But we need to work together, or we're not going to solve this problem. But presently, in the United States, both political parties take money from the military-industrial complex, from the fossil fuel industry, from the pharmaceutical industry, from the gun industry. And so the public has a lot of things they would like to see get done, but they don't happen. There's a reason. our democracy is no longer functioning as a democracy. You have to get the role of money out of government. And the amazing thing is that young people have the power to make that happen. I was on a university campus in 2008 when Hillary Clinton was expected to be the Democratic candidate for president. She was the preferred candidate of that political party. But young people were started to like Barack Obama, and they managed to get him to get the nomination. It was only because all these young people got involved. So, and there's another case that happened again where Bernie Sanders, who could never get elected, but young people at all the campuses on the country almost got him to get a nomination. So the young people have tremendous potential to affect the political system, but they have to know what needs to get done. And I think we have, in the United States, we have to have a party that takes no money by definition. And the thing about young people is they communicate with social media. They don't need billions of dollars for a campaign. They can do it completely free of charge. So if that doesn't happen, we're in trouble with the climate problem because it's not going to be solved as long as the special interests are controlling our governments. And okay, I'm done. But I went to, a dozen countries, and they're not as bad as the special interest situation in the U.S., but there's still, the fossil fuel industry has a big impact, which has to be addressed. Thanks.
Thank you so much, Jim. We have a lot to discuss after that, so I will now quickly welcome to the stage Clare Farrell.
Thank you.
Hello, everybody. Can you hear me? Yeah? Okay. Hello. And thank you very much for that, Jim. I'm really glad that you were closing on the spirit of asking us what kind of ancestors we want to be. Who are we? I really respect your work, especially the courage with which you've brought forward the message that people need to hear. I think there's a distinct lack of eldership, and whilst people pin their hopes on the youth of today, I often want to point straight back at the elders and say, what on earth are you doing? What are you doing with your life? What are you doing with your money? What are you doing with your property? What are you doing with your work? Have you redirected your career? Have you changed what you're doing in your life in any substantial way? Because it is not okay to talk about young people unless you're helping them. And so I just wanted to ask you, one of the things that you're very good at, Jim, is bringing stories like you just have from the Bible and the Faustian bargain, which helps people to orientate themselves around work which you do, which is very complex. Because we do have a lot of stories that we could be making better use of, myths, stories from faith communities. We have a lot of wisdom in our history of humanity, which often doesn't get much airtime in this space because people are very fixated in the West with science. So I wanted to ask, could you say a few things about the fossil fuel industry? I know hid work on the impact of fossil fuels, but they also hid James Lovelock's research on aerosols, as I understand, that he was commissioned to do some work. He found the masking effect of aerosols a long time ago. And the fossil fuel sector, not only did they hide the fact that it would warm the planet, they also hid the fact that we would not notice very quickly that that would happen. I wonder if you can say a few things about that.
You know, with regard to fossil fuels, I should say, first of all, fossil fuels are enormously valuable. You know, one gallon, which is 3.8 liters of petrol, contains the equivalent of 400 hours of labor by an adult. So fossil fuels have brought the standard of living most of the world up to where it is. So we shouldn't be, we need to understand the fossil fuel industry has a good point. They argue that, well, they're improving people's lives. And they have, but unfortunately, there's this side effect which has to be dealt with. And as long as they are able to put the waste products of fossil fuels in the atmosphere without charge, we won't solve this problem. That's why on my last list of 3 things, the first thing is you have to have a rising carbon fee, which you can collect from very easily at the domestic mines or in the ports of entry. But the public will never accept that, at least in the United States, unless that money goes to the public. And so it's very easy to do that. I started preaching that almost 20 years ago, and several years later, several thousand economists got together and agreed exactly with that prescription, that you have to collect a rising carbon fee, distribute the money to the public, an equal amount to each legal resident of your country. Then 70% of the people actually get more in their dividend than they pay in increased prices. It's wealthy people will lose money because they have a big carbon footprint, but they can afford it. So it's a very easy prescription. The only thing is the fossil fuel industry can't understand, that would actually work. And that's going to phase down the use of fossil fuels. But we have to do that. Unless the carbon is captured, then they can figure out a way to capture the CO2 and still use a fossil fuel. But more likely we'll move to other clean energies. Mm-hmm. So I think I avoided answering directly your question because it's the crucial point, which you know, there was this great person, Ted Halstead, who understood this. I talked to him early on, and he was very effective in getting conservative politicians, James Baker III, the Secretary of State in the Reagan administration, and these people to come out in favor of carbon fee and dividend. And then even the college students, the student body presidents of all the universities in the country agreed, we should do this. Unfortunately, Ted Halstead went mountain climbing and had an accident and fell to his death. So that project has been stalled, but that's the most fundamental thing that needs to get done. We have to be sensible about this. You can't, the public recognizes that they're getting a lot of benefits from fossil fuels, so it's not going to go away easily if you don't have a sensible alternative and introduce it in a way that would work.
Yeah, sure. I think that the decarbonisation agenda in the UK is becoming increasingly partisan, politicised. I've been living in a situation which is very different to yours, where people from many sides of the political spectrum would historically have advocated in the direction of recognising climate change, accepting that it's real, and then making political decisions to move towards dealing with it. Of course, not in any way that I think is legitimate in comparison with the scale of our problems, but it's being politicised more and more. And I think, you know, the challenge that we all face in this increasingly sort of fractured world, and I guess this is also something about your energy imbalance framing, which changed my perspective on what we could talk about, both scientifically, technically, and politically, is that for people to understand, yes, there is an invisible gas that traps energy, but the problem is if you look at the problem as the energy itself, which is an energy imbalance frame, it's very different from a very long-term kind of carbon pollution kind of frame, which feels like it's been around for my entire lifetime, saying, well, stop polluting, stop polluting. And that increasingly sort of becomes kind of jaded, I think, in people's minds. What I was interested with your work recently on sensitivity, but especially earth energy imbalance as a concept, was that it gives you the ability to go to some people who, particularly maybe conservatives, who feel like they're on a side already of this, and say, actually, there's new information. There's potentially some new frames that we could look at this through. There are new propositions for the nature of our predicament. And importantly, Jim, your paper, once it was peer-reviewed and said, you know, we think that the aerosols are the second most significant forcing in the whole Earth system. As soon as that peer review landed, I felt that the whole climate movement is actually working in a different world. Because we knew that the aerosol thing was there, but actually everybody, including at the beginning of XR, would say to us, from the scientific community especially, you can't talk about that because we don't know. We don't know, so leave it out. Don't include it. It's not part of the conversation. But it's kind of sudden entry, in my view, into the space via your recent work does give us, I think, a new context from which to talk about the nature of the crisis, the urgency of the crisis. There's all sorts of possibility. And I'm interested in how we make more space, because we often feel quite constricted. So what have you noticed about the way that your work has landed and the way that it may be able to help the discourse? Okay, so there are two basic issues she's raised. One of them is the energy imbalance. You know, this goes back to the year 1988 when I testified. Climate became a big issue, and NASA was able to get money for a big program called initially Mission to Planet Earth, and it led to this Earth observing system. One very successful instrument that came out of that measures the Earth's radiation balance, the amount of heat radiated by the planet and the amount of sunlight that's reflected by the planet. So we can measure, and we can measure very precisely that now that there's more energy coming in than going out, which is the expected effect of adding greenhouse gases to the atmosphere because they block the outgoing radiation. But we can measure that very precisely, and as I mentioned in my talk, it's more than 1 watt per meter squared, which means that there's a lot of additional warming that has to occur. There's more energy coming in than going out. The planet has to get warmer. So that's a very useful information. Unfortunately, what the NASA system does not measure is the aerosol forcing. And that's a whole story of itself. I have an incomplete book, which is called The End of the Rainbow, which is about aerosols. My career started with aerosols, and I proposed with my colleagues an instrument that was selected to go on the Pioneer Venus mission. And we successfully measure the aerosols on Venus. We know the properties of the aerosols on Venus much more accurately than we know them on the Earth. Because, and I deserve some of the blame for us not measuring aerosols, because I criticized NASA's plan to put all instruments on one giant satellite, which I called Battlestar Galactica. And so they threw our instrument off. And we're still not measuring aerosols. So we have to infer them indirectly.
as I've described. And now, finally, after decades, we can see from the combination of the different measurements that are available, especially the radiation balance, that aerosols are a significant cooling. And they have offset about a third of the warming. But now, as we begin to reduce that aerosol pollution, we're getting that additional warming. That's why warming accelerated.
Yeah. I have also, some time ago, been in touch with one of your co-authors, Leon Simons, to talk with him about the aerosols work that you've done, and especially his communication about it, because he's become very dedicated to trying to communicate these issues. And obviously I'm also looking at the climate intervention space, and there's an enormous concern about solar radiation interventions of various types, but especially in the stratosphere. Lots of people very worried about that. And the biggest concern that you hear very loudly is about this thing called a termination shock, right? So the idea that you can make an intervention, but if something happens to your supply chains, or if you have to stop, or when you stop, there'll be a sudden impact of extreme warming. And I'm very curious.
That's baloney.
Well, I'm very curious, Jim, about the research that you've done and the way that it relates to the changes in the shipping fuel regulations. Because I have been asking people when I meet scientists, experts, don't you think we are living through a termination impact shock event because of what the IMO did? And most people just say, no, I don't know what you're talking about, Claire. But it seems to me that if you suddenly take all the sulfur out of shipping fuel and then this happens, and then we have to think about whether what's happening now.
Yeah, I don't mean to, by saying it's baloney, I just say it's exaggerated. Yeah, that's exactly what we have. This was a big change. They reduced the sulfur content, the International Maritime Organization changed its regulations and reduced the allowable sulfur content of fuels very sharply. And that is, I think, the main reason that for the global aerosol reduction, and that's the cause of the acceleration in warming. So instead of continuing to warm at 0.2 degrees Celsius per decade, it's gone up to 0.3 to 0.4. It's increased at least 50%, if not doubling, over the last 10 to 15 years. So that's the termination shock. But I mean, you know, it's a change in the rate of the global temperature change. It's not something, the termination shock idea sounds a little more extreme. It's just affecting the energy balance enough that it's going to change the rate of temperature change. So to use that as a reason not to use aerosol cooling, it doesn't really make sense, in my opinion. But the priorities have to be getting down the emissions of the problem, you know, the greenhouse gases. And that's why I have number one thing of my three is you have to put a price on carbon. If we're not doing that, then I would not suggest trying to cool the planet. We can't continue to increase warming and the cooling and think that's going to be a solution. We've got to address the fundamental problem first.
Yeah. And I mean, I think that we are living in a time of needing to pay attention to some very complex issues before us. There are many things we need to do all at the same time, precisely because of the delay in any kind of meaningful response. I know that, you know, what your work has shown to everybody is also this sort of vast importance of albedo and the vast importance of clouds in that. Do you notice within the research community or anywhere else that there's like an increased attention, therefore, to the other things that are involved in cloud seeding, forest cover, plankton? There are natural cloud seeding mechanisms going on in the Earth system, and presumably those are now of immense importance to the climate story. Are you noticing a sort of a change in anyone's focus? Are people sharpening their minds around clouds at all?
Well, clouds have always been the big uncertainty in climate modeling. That was the uncertainty when Charney's report in 1979. The reason for his big range was we understand things like the ice albedo feedback and water vapor. As the atmosphere gets warmer, we know how much additional water vapor it will hold, and those are big feedbacks. But the third big feedback is clouds, and that one is complicated. And the problem is clouds are also a forcing, because we can change clouds by means of various means, but the aerosol effect is mainly via the effect of aerosols on clouds. So this is very complicated. That's why we needed to be monitoring the microphysics of aerosols and cloud particles from satellites. That is what we proposed to do in the 1980s, and it has just not happened. You have to measure the polarization of the sunlight reflected by the planet to an accuracy of 0.1%. There's a brilliant French astronomer, Bernard Leo, who developed a technique to measure polarization to 0.1%. And that's what we used that technique on our Venus instrument. We need to do that for Earth orbiting instruments, and you need to look at the Earth from different angles to make full use of the polarization. So that's why I didn't want everything on one big satellite. You have to have small satellites. But yeah, that's still a hard issue to get that microphysics right.
Yeah, and also the idea of getting things as complex as this right, in inverted commas, is enormously problematic in itself, isn't it? I think.
Well, if you have now with artificial intelligence, you could, if you had a satellite making these measurements, it's a complex analysis of the problem, which was one of the criticisms that we had people had of our work several decades ago as well. This is going to be so hard. How can you possibly analyze that Earth data? Well, now with AI, you could analyze complex satellite data very well and get detailed information on the microphysics of the aerosols and the cloud particles.
Yeah, I guess one of the things that I've tried to sort of pull forward through the work of Extinction Rebellion always was to encourage us to think in ways that perhaps bring forward a little bit of humility about our own limitations as humans, that we can make mistakes. There are lots of things that we may not understand. It seems that we've got very serious problems in our human systems, that we don't even understand how to change each other or the way that we run our economies or the way that we govern ourselves in our countries.
Or maybe they do understand, and that's the problem, that special interests have learned how to make our government work in their interest. But in a democracy, it's supposed to be working in the public's interest.
Yeah.
And that requires getting money out of the government.
Yeah. Yeah, I'm glad that you said that we don't really live in a real democracy. I mean, in the UK at least, the space for our voice has been shrunk in a very extreme way, even by both sides on the political spectrum, and in favour of a kind of authoritarian clampdown. And a friend of mine has described the restriction on freedom, particularly for young people, to be able to protest, to be able to resist, to be able to dissent in our political reality, as making them into a kind of climate hostages, basically, with their, like you say, with their hands tied behind their back, but not just because of the technical guys who decided to take the options off the table, but also because of the politicians saying, and now you can't fight back, now you can't even shout loudly at me because I'll throw you in jail, basically.
Well, see, I think that it's important. I've had to, I've been arrested several times myself.
Me too.
but you have to be careful about that. You shouldn't, if people inconvenience the public with actions to draw attention, that tends to backfire. What we have to do is to get democracy to work for the people, and that requires figuring out how that political system works.
Or make a new one.
Pardon?
Or make a new one, which is what we're working on in the UK.
Well, yeah, you need in the U.S., the two political parties have cleverly fixed things, so it's very difficult for any competition. Mm-hmm. But it's possible. And one of the key things needed to make that happen is ranked voting, so that a third-party candidate does not spoil the election and end up getting the worst candidate elected. Yeah. So there are now organizations in every state in the U.S. working for an organization called Rank the Vote to try to get, because you have to do this on a state-by-state basis. Mm-hmm. But that's the kind of thing which has to be done to make our democracy work the way it was intended.
Sure. Okay, so I'm getting waved at. We've got to ask some questions from the audience. I'm sorry, I don't have a clock in front of me. So I can see there's one here. Do we have some more? Let's take a couple at the same time, if possible. One at the front, one at the back.
Thank you. Thank you very much. My name is Matti Vainio. I'm a professor of practice in green transition here at the University of Helsinki. There's some good things happening in the US as well. And the good thing that happened was sulfur trading. As a result of that success, Europe took on trading on carbon. And the good news is that we have at the moment a price of carbon in Europe, in all countries, which is 80 euros per ton of CO2. So there's actually good things happening as well. We don't see that because the market is taking care of it. The other good thing that happened in Europe at least, and I think also in the US, is the uptake of wind and solar energy. And you didn't mention that very much in your presentation, but it actually has been tremendously successful, not because of Europe, but because of China. And the cooperation through markets with China is actually working as well, as long as we don't put 100% or 200% tax duties on it. So I was wondering if you could comment on those kinds of market developments which are real, which are happening, and the decarbonization at least is happening in Europe and also in China because of emissions trading over there. So how could something like that happen in other places as well, so that we would get the price on carbon so that at least number one of your tick boxes would be taken care of? Thank you.
Yeah.
Okay.
Let's take another one.
Yes, there are good things happening. They're not happening fast enough is the problem. And that's why we're going to pass 2 degrees. So, I'm actually optimistic that you can see that we are finally going to hit that peak in CO2 emissions and begin to go down. but it needs to go down faster. And although you say there's a carbon price, well, there is a limited carbon price, but it needs to be in a simple way that's across the board and in a way that you can make it global by means of border duties on products from countries that do not have a carbon price. And again, Europe is the leader in trying to get border duties, for example, but frankly, the cap and trade with offsets is a tricky business. So in principle, you have a price on carbon, but it's not covering everything. And it's not going to rise at the rate that's needed because the public doesn't want it. If the public's not, you know, it becomes a technical argument, but the cap and trade with offsets is not as effective as a simple across-the-board carbon fee collected at the source so you cover everything. There are too many exceptions in the rules the way they're now written, and too many ways for politicians and the industry to twiddle things so that it's not as effective as it should be. I know you're shaking your head, but if you look at the emissions, they're still right now going up, and they've got to go down fast. But it is what's happened in China. I've gone there several times and organized workshops with China and India scientists. So I think it's important that we make those connections and encourage governments to take action. But the cooperation with China is not really happening to the degree that it needs to. We had the potential, for example, if you want next generation nuclear power to come into play, you know, for so many decades it was just denied, and now suddenly people say, oh, you got a triple nuclear power. Well, thanks very much, but it's not ready. The next generation is not ready. We should have been subsidized, we should have been working on that the way we did on solar and wind. Then we could move down rapidly in our carbon emissions. But to do that now, we should work with China because they can build things quickly. And we're refusing to do that. And especially it's the U.S. that doesn't want to work with China. It wants to focus on global hegemony in economics and military.
Do we have time for one more question quickly?
Let's take two at the same time. So Jim, wait for both questions.
Thank you.
Yeah, thank you for the insights. I'm Veikko Sainen, work as a sustainability consultant. I will be very quick. Where does the animal agriculture sit in all of this? And we're basically waging a war against nature, so we're reducing nature's capacity to absorb CO2, and that hasn't really been mentioned today yet. Thank you.
Thank you. And one more down here.
Yeah, thanks. Thanks, I'm Anton. Thanks, Claire. Thanks, James. Quick question. James, you said disrupting the public with actions on the streets usually backfire, but we have several examples from history where liberation movements have used these tactics, and climate movement has been relatively successful. For example, the action, Claire, you have taken is a big part of why we are now here, from XR Finland, etc. So is there some, this is for both of you, what are the possibilities of direct action?
Thanks very much. Well, Jim, what do you think about this? I mean, we haven't said anything about animal agriculture. We haven't touched on the war, the assault on the natural world. I mean, it's a very different conversation to sort of making small arguments for and against trading and taxes and friction on economic stuff. If you've got some comment on the living world and the Earth system and the other beings, just quickly.
I don't understand the question.
Well, when we launched Extinction Rebellion, we called it Extinction Rebellion because we're in an extinction event. You know, lots of people saw the carbon and the climate issue as separate to the kind of war that we waged on the living world in other ways. I just wonder if you have some thoughts about the combination of the two issues at this time.
Well, nature actually is trying to help us. You know, it's quite remarkable. I showed this one chart called the airborne fraction. And I mentioned that after the Pinatubo eruption, nature took up 75% of our emissions in both of those years. But just on average, over the last 50 years, it's been taking up 45% of our emissions. So if we cut our emissions in half, the CO2 would stop growing. But we actually need to get it to decrease, so we need to reduce more than 50%. But nature is very resilient and is trying to help us. But if we keep hammering it with more extreme rates of change, then there can be failures in nature, as we're seeing with the coral reefs, for example. Yeah. So if we just would slow things down, then nature will do fine.
Yeah. Well, and just to close on Anton's question there about disruptive action, I mean, I think as much as we are seeing in the political system, there's sometimes a backfire and a backlash against action. Of course, this movement for climate action is going to have to ask very serious questions, I think, about the nature of our economic system. We have a relational problem, our relationship to animals, our relationship to one another, our relationship to other countries. Everything is thrown into question by this. We have such severe systemic problems within our human systems that, of course, when you say we have to tackle this problem now because it's the end of us, you know, messing around and wasting time, people are going to push back on you for that. And I'm not surprised that people have come at us with amazing strategies from the think tanks, from politicians, to try and make sure that movements that are succeeding in turning public opinion are crushed, and that dissent becomes impossible, or that resistance becomes more difficult. But it is possible for people to make political change happen in the most extraordinary conditions. And indeed, some of the inspirations for Extinction Rebellion came from movements that have moved on from dictatorships and so on, people working in much more difficult working conditions as a resistor than the ones that we have had in recent times, in my lifetime anyway, in the UK. So there is still a lot of possibility and potential, and we have to be very creative. And I also think that we have to be open to building new systems, making new institutions. I'm impressed with these guys for setting up their own organizations. So in such a mature way to take on something which is difficult, and in a way which lots of adults in the room are saying, oh, well done, you young people, to the Operaatio Arktis people, crew. So, you know, we have to make a lot of new systems and a lot of new spaces and create more room for more action and more conversation and new stories together. And that's what we're in the business of doing, I think, here at the moment. And that is going to be the rest of my life's work, as far as I can see, because of the type of world that we now have to work in and live in. So, yeah, have you got some closing words for us, Jim, to finish the session?
Well, I think we have to get our democracy, we have to save our democracies and get them to work as democracies are intended to work for the public. And we can do that. So we have to focus on that rather than, I think that should be first priority.
Let's build a new world together, people.
Thanks.
Thank you so much. I just have a minute to wrap this all up. Thank you so much for being here. I just wanted to briefly touch on what Jim said earlier. Jim made a really compelling argument on remaining open to these novel approaches such as sunlight reflection methods. And yeah, I mean, we've been geoengineering this planet for centuries now, and that has led to this moment where we are on the threshold of crossing multiple Earth system tipping points. And yeah, at the same time, we are really concerned about these risks in relation to these approaches as well. And obviously, like, there's no plan B for drastic emission reductions. Decarbonization is the only sustainable road in the long run, whether we, you know, supplant it with these novel approaches or not. We need a very critical, thorough investigation. We need very multi-voiced deliberation on these technologies as well. So I urge you to keep this conversation going. I really want to again applaud Jim and Claire for what they've done. I mean, these are people who have really devoted their lives to this struggle and taken real risks, you know, for example, on their careers, I imagine, in doing this. And that is definitely courage that, you know, we should all embody at this moment in time. Thank you all so much for being here.